The chemicals in clay used to make pottery can differ depending on the geographical region where the clay originated. Sometimes archaeologists use a chemical analysis of clay to help identify where a piece of pottery originated. Such an analysis measures the amount of chemical in the clay as a percent of the total weight of the piece of pottery. The box plots below summarize analysis done for the three chemicals, X, Y, and Z, on pieces of pottery that originated at one of the three sites, 1, 2, or 3. For chemical Z, describe how the percents found in the pieces of pottery are similar and how they differ among the three sites. This question is asking for you to find the similarities and differences between multiple sets of data in the form of a box plot.
We can use the acronym SOX to help us compare and contrast chemical Z in the three different sites. S stands for shape, O stands for outliers, C stands for center, and S stands for spread. For chemical Z in all three sites, the shape is approximately symmetric and there appears to be no discernible outliers. The median for chemical Z in all three sites is about 7% of total weight of the piece of pottery. Finally, the range of chemical Z in Site 1 is 6%, ranging from 4% to 10%. In Site 2, it's 2%, ranging from 6% to 8%. And in Site 3, it is 8%, ranging from 3% to 11%. Therefore, they are similar in that they are all approximately symmetric, have no discernible outliers, and have a median of about 7%, and differ in that they have different ranges.
Consider a piece of pottery known to have originated at one of the three sites, but the actual site is not known. Suppose an analysis of the clay reveals that the sum of the percents of the three chemicals X, Y, and Z is 20.5%. Based on the box plot, which site, 1, 2, or 3, is the most likely site where the piece of pottery originated? Justify your choice. The best way to determine if the sum of the percents of the three chemicals are equal to 20.5% is by adding all the maximum values in each site and adding all the minimum values in each site in order to create an interval that includes all the possible total percents by weight of each site.
The interval created for Site 1 ranges from 21% to 33%, which does not possess the value of 20.5%. The interval created for Site 2 ranges from 12.9% to 19%, which also does not possess the value of 20.5%. The interval created for Site 3 ranges from 14% to 26.5%, the only site to contain the value of 20.5%. Therefore, Site 3 is the most likely site where the piece of pottery originated. Suppose only one chemical could be analyzed in the piece of pottery. Which chemical, X, Y, or Z, would be the most useful in identifying the site where the piece of pottery originated? Justify your choice. The question is asking us to choose one chemical in a piece of pottery that would single-handedly tell us exactly where that piece of pottery originated from. Therefore, we would want to choose a chemical that has a unique and different value for it in each site.
Chemical Y would be the most useful in identifying the site where the piece of pottery originated from because there is no overlap in the distribution of the percentages for chemical Y in the three sites. This means if we determine the percentage of total weights of chemical Y in the pottery, we know definitely where it came from. Chemicals X and Z would not be useful because they each have overlaps in percentages of total weights, which means if we do have an overlap of percent for a chemical in two sites, we would not know for which site the chemical came from.